Hi everyone, this is 𝐑𝐨𝐿𝐴 from Edureka. Today's session is dedicated to reinforcement learning. Reinforcement learning is one of the types of machine learning which has been growing in the past few years. It has various applications like self-driving cars and image processing techniques wherein you detect objects using reinforcement learning. Reinforcement learning has become one of the most important types of machine learning in today's world. So without any further ado, let's look at what we're going to cover today. So we're going to begin the session with an introduction to machine learning and the types of machine learning. After that, we'll discuss reinforcement learning in depth and we'll try to understand reinforcement learning with an analogy. Once we're done with that, we'll look at the reinforcement learning process and how it works. And then we'll try to relate the reinforcement learning process with a Counter-Strike example. Once we're done with that, we'll look at a few reinforcement learning definitions like agent, environment, action, and so on. Next, we'll move on to the reinforcement learning concepts. Here, we'll discuss a few concepts such as reward maximization and the concept of exploration and exploitation. Then we'll finally move on to the Markov's decision process, where we'll try to understand this process with the help of a shortest path problem. Now, moving on to the demo, we'll be implementing the Q-learning algorithm. So in order to understand the demo, we're going to first discuss the Q-learning algorithm with an example, and we'll see how the Q-learning algorithm works. After that, we'll move on to the hands-on part, where we'll be placing an agent in an unknown environment and he has to figure his way out of the environment. Alright, so guys, this is a very interesting demo. So let's start with our first topic, which is Introduction to Machine Learning. So what is machine learning? Now, machine learning is the science of getting computers to act by feeding them data and letting them learn a few tricks on their own. Okay, so you're not actually programming the machine, but instead you're feeding the machine a lot of data so that it can learn by itself. All right. So let's try to understand this with an example. So as kids, we wouldn't be able to differentiate between the different fruits like apple, cherry, and orange. When we first see how apples, oranges, and cherries look, we won't be able to differentiate between them. This is because we haven't observed them enough. All right. We don't have enough data about how apples look. We don't know how cherries look, and we don't know how oranges look. So we can't differentiate among them. But as we grow up and we learn how apples look, we know that they're red in color and we know how cherries are smaller when compared to apples. We learn how to differentiate between the fruits. Similarly, when it comes to a machine, if you input images of an apple, orange, and cherry to a machine, initially it won't be able to differentiate between the three. Now, this is because it doesn't have enough data about them. But if you keep feeding hundreds and thousands of images to the machine about cherries, apples, and oranges, it'll learn how to differentiate between the three. Just like how we humans learn by looking around and observing and collecting data, similarly, machines also learn when you give them a lot of data. Alright, so when you input a lot of data to a machine, it'll learn how to distinguish between them. So the machine will basically train on the data and it'll try to differentiate between the various fruits by using various machine learning algorithms. Now let's move ahead and look at how machines learn. There are three different types of machine learning. Okay, so first we have the supervised learning. Now, supervise means to direct a certain activity and make sure it's done correctly. Alright. So as children, when we attended school, we needed a lot of guidance from our teachers. Alright. We couldn't solve a simple math problem if our teachers didn't practically show us how to do it. Okay. So we always needed a guide, which was basically the teacher. But later on, we picked up our own pace. We learned how addition was done, how subtraction was done. Alright. But initially, we did need a little bit of guidance. Now, this is exactly how supervised learning works. So if you feed the model a set of data called the training data, which contains both the input and the corresponding expected output. Okay, so this training data will act like a teacher and it will teach the model the correct output for a particular input. So this was about supervised learning. Now, unsupervised means to act without anyone's direction or anyone's supervision. So guys, when a child grows into an adult, he no longer needs someone to guide him at every step. Okay, so he observes and he learns without any help. And this is exactly how unsupervised learning works. In this method, the model is basically given a data set which is neither labeled nor is it classified. So the machine doesn't know, okay, this is the input, so this is how the output should look. Which means that if you input an image of a fruit, you're not going to label it as apple. Okay, instead you're just going to give it data and the machine is going to learn on its own. Alright, so next we have reinforcement learning. Now, reinforcement means to establish or encourage a pattern of behavior. So guys, what would happen if you were dropped off, let's say, at an island, okay, at an isolated island? Initially, you'd panic and be unsure of what to do. where to get food from, how to live, and all of that. But after a while, you have to adapt. You must learn how to live in the island, adapt to the changing climates, learn what to eat and what not to eat. Okay, so basically, you're following the hit and trial concept because you're new to the surrounding. And the only way to learn is to experience and then learn from your experience. This is exactly what reinforcement learning is. It is a learning method wherein an agent, which is basically you stuck on the island, interacts with its environment, which is the island, by producing actions and discovering errors or rewards. Now, moving on, I'll be discussing more about reinforcement learning. So let's look at some of the examples and let's define what reinforcement learning really is. So guys, reinforcement learning is a part of machine learning where an agent is put in an environment and he learns to behave in this environment by performing certain actions. Okay, so it basically performs actions and it either gets rewards on the actions or it gets a punishment and observing the reward which it gets from those actions. Reinforcement learning is all about taking an appropriate action in order to maximize the reward in a particular situation. So guys, in supervised learning, the training data comprises of the input and the expected output. And so the model is trained with the expected output itself. But when it comes to reinforcement learning, there is no expected output. Here, the reinforcement agent decides what actions to take in order to perform a given task. In the absence of a training data set, it is bound to learn from its experience itself. All right. So reinforcement learning is all about an agent who is put in an unknown environment and he's going to use a hit and trial method in order to figure out the environment and then come up with an outcome. Okay. Now let's look at reinforcement learning with an analogy. So consider a scenario wherein a baby is learning how to walk. This scenario can go about in two ways. Now in the first case, the baby starts walking and makes it to the candy. Here the candy is basically the reward it's going to get. So since the candy is the end goal, the baby is happy. It's positive. Okay, so the baby is happy and it gets rewarded a set of candies. Now another way in which this could go is that the baby starts walking but falls due to some hurdle in between. The baby gets hurt and it doesn't get any candy and obviously the baby is sad. So this is a negative reward. Okay, or you can say this is a setback. So just like how we humans learn from our mistakes by trial and error, reinforcement learning is also similar. Okay, so we have an agent, which is basically the baby, and a reward, which is the candy over here. Okay, and with many hurdles in between. The agent is supposed to find the best possible path to reach the reward. So guys, I hope you all are clear with the reinforcement learning. Now let's look at the reinforcement learning process. So generally, a reinforcement learning system has two main components. All right, the first is an agent and the second one is an environment. Now, in the previous case, we saw that the agent was the baby and the environment was the living room wherein the baby was crawling. Okay, the environment is the setting that the agent is acting on and the agent over here represents the reinforcement learning algorithm. So guys, the reinforcement learning process starts when the environment sends a state to the agent and then the agent will take some actions based on the observations. In turn, the environment will send the next state and the respective reward back to the agent. The agent will update its knowledge with the reward returned by the environment and it uses that to evaluate its previous action. So guys, this loop keeps continuing until the environment sends a terminal state, which means that the agent has accomplished all his tasks and he finally gets the reward. Okay, this is exactly what was depicted in this scenario. So the agent keeps climbing up ladders until he reaches his reward. To understand this better, let's suppose that our agent is learning to play Counter-Strike. Okay, so let's break it down. Now, initially the RL agent, which is basically the player one, let's say it's the player one who is trying to learn how to play the game. Okay, he collects some state from the environment. Okay, this could be the first state of Counter-Strike. Now, based on this state, the agent will take some action. Okay, and this action can be anything that causes a result. So if the player moves left or right, it's also considered as an action. Okay, so initially the action is going to be random because obviously the first time you pick up Counter-Strike, you're not going to be a master at it. So you're going to try with different actions and you're just going to pick up a random action in the beginning. Now the environment is going to give a new state. So after clearing that, the environment is now going to give a new state to the agent or to the player. So maybe he's crossed stage 1, now he's in stage 2. So now the player will get a reward R1 from the environment because it cleared stage 1. So this reward can be anything. It can be additional points or coins or anything like that. Okay, so basically this loop keeps going on until the player is dead or reaches the destination. Okay, and it continuously outputs a sequence of states actions, and rewards. So guys, this was a small example to show you how reinforcement learning process works. So you start with an initial state, and once the player clears that state, he gets a reward. After that, the environment will give another stage to the player, and after it clears that state, it's going to get another reward, and it's going to keep happening until the player reaches his destination. Alright, so guys, I hope this is clear. Now let's move on and look at the reinforcement learning definitions. So there are a few concepts that you should be aware of while studying reinforcement learning. Let's look at those definitions over here. So first we have the agent. Now an agent is basically the reinforcement learning algorithm that learns from trial and error. Okay, so an agent takes actions like, for example, a soldier in Counter-Strike navigating through the game, that's also an action. Okay, if he moves left, right, or if he shoots at somebody, that's also an action. Okay, so the agent is responsible for taking actions in the environment. Now the environment is the whole Counter-Strike game. Okay, it's basically the world through which the agent moves. The environment takes the agent's current state and action as input, and it returns the agent's reward and its next state as output. Alright, next we have action. Now all the possible steps that an agent can take are called actions. So like I said, it can be moving right, left, or shooting, or any of that. Alright, then we have state. Now state is basically the current condition returned by the environment. So whichever state you are in, if you're in state 1 or if you're in state 2, that represents your current condition. Alright, next we have reward. A reward is basically an instant return from the environment to appraise your last action. Okay, so it can be anything like coins or it can be additional points. So basically a reward is given to an agent after it clears the specific stages. Next we have policy. Policy is basically the strategy that the agent uses to find out his next action based on his current state. Policy is just the strategy with which you approach the game. Then we have value. Now value is the expected long-term return with discount. So value and action value can be a little bit confusing for you right now, but as we move further, you'll understand what I'm talking about. Okay, so value is basically the long-term return that you get with discount. Okay, discount I'll explain in the further slides. Then we have action value. Now action value is also known as Q value. Okay, it's very similar to value except that it takes an extra parameter, which is the current action. So basically here you'll find out the Q value depending on the particular action that you took. Alright. So guys, don't get confused with value and action value. We'll look at examples in the further slides and you'll understand this better. Okay, so guys, make sure that you're familiar with these terms because you'll be seeing a lot of these terms in the further slides. Alright, now before we move any further, I'd like to discuss a few more concepts. Okay, so first we'll discuss the reward maximization. So if you haven't already realized it, the basic aim of the RL agent is to maximize the reward. Now, how does that happen? Let's try to understand this in depth. So the agent must be trained in such a way that he takes the best action so that the reward is maximum. Because the end goal of reinforcement learning is to maximize your reward based on a set of actions. So let me explain this with a small game. Now in the figure you can see there is a fox, there's some meat and there's a tiger. So our agent is basically the fox and his end goal is to eat the maximum amount of meat before being eaten by the tiger. Now since the fox is a clever fellow, he eats the meat that is closer to him rather than the meat which is closer to the tiger. Now this is because the closer he is to the tiger, the higher are his chances of getting killed. So because of this, the rewards which are near the tiger, even if they are bigger meat chunks, they will be discounted. So this is exactly what discounting means. So our agent is not going to eat the meat chunks which are closer to the tiger because of the risk. Alright. Now, even though the meat chunks might be larger, he does not want to take the chances of getting killed. Okay, this is called discounting. Okay, this is where you discount because you improvise and you just eat the meat which are closer to you instead of taking risks and eating the meat which are closer to your opponent. Alright. Now, the discounting of reward works based on a value called gamma. We'll be discussing gamma in our further slides, but in short, the value of gamma is between 0 and 1. Okay, so the smaller the gamma, the larger is the discount value. Okay, so if the gamma value is lesser, it means that the agent is not going to explore and he's not going to try and eat the meat chunks which are closer to the tiger. Okay, but if the gamma value is closer to 1, it means that our agent is actually going to explore and it's going to try and eat the meat chunks which are closer to the tiger. Alright, now I'll be explaining this in depth in the further slides, so don't worry if you haven't got a clear concept yet. But just understand that reward maximization is a very important step when it comes to reinforcement learning, because the agent has to collect maximum rewards by the end of the game. All right. Now let's look at another concept which is called exploration and exploitation. So exploration, like the name suggests, is about exploring and capturing more information about an environment. On the other hand, exploitation is about using the already known exploited information to heighten the rewards. So guys, consider the fox and tiger example that we discussed. Now here the fox eats only the meat chunks which are close to him, but he does not eat the meat chunks which are closer to the tiger. Okay, even though they might give him more rewards, he does not eat them. If the fox only focuses on the closest rewards, he will never reach the big chunks of meat. Okay, this is what exploitation is about. You're just going to use the currently known information and you're going to try and get rewards based on that information. But if the fox decides to explore a bit, it can find the bigger reward, which is the big chunks of meat. This is exactly what exploration is. So the agent is not going to stick to one corner. Instead, he's going to explore the entire environment and try and collect bigger rewards. All right. So guys, I hope you all are clear with exploration and exploitation. Now let's look at the Markov's decision process. So guys, this is basically a mathematical approach for mapping a solution in reinforcement learning. In a way, the purpose of reinforcement learning is to solve a Markov decision process. Okay, so there are a few parameters that are used to get to the solution. So the parameters include the set of actions, the set of states, the rewards, the policy that you're taking to approach the problem, and the value that you get. Okay, so to sum it up, the agent must take an action A to transition from a start state to the end state S. While doing so, the agent will receive a reward R for each action that he takes. So guys, a series of actions taken by the agent define the policy, or it defines the approach. And the rewards that are collected define the value. So the main goal here is to maximize the rewards by choosing the optimum policy. Alright, now let's try to understand this with the help of the shortest path problem. I'm sure a lot of you might have gone through this problem when you were in college. So guys, look at the graph over here. So our aim here is to find the shortest path between A and D with minimum possible cost. So the value that you see on each of these edges basically denotes the cost. So if I want to go from A to C, it's going to cost me 15 points. Okay, so let's look at how this is done. Now before we move and look at the problem, in this problem the set of states are denoted by the nodes, which is A, B, C, D, and the action is to traverse from one node to the other. So if I'm going from A to B, that's an action. Similarly, A to C, that's an action. Okay. The reward is basically the cost, which is represented by each edge over here. All right. Now the policy is basically the path that I choose to reach the destination. So let's say I choose A, C, D. Okay. That's one policy. In order to get to D, I'm choosing A, C, D, which is a policy. Okay. It's basically how I'm approaching the problem. So guys, here you can start off at node A and you can take baby steps to your destination. Now, initially you're clueless, so you can just take the next possible node which is visible to you. So guys, if you're smart enough, you're going to choose A to C instead of A, B, C, D or A, B, D. Alright. So now if you're at node C, you want to traverse to node D. You must again choose a wise path. Alright. You just have to calculate which path has the highest cost or which path will give you the maximum rewards. So guys, this is a simple problem. We're just trying to calculate the shortest path between A and D by traversing through these nodes. So if I traverse from ACD, it gives me the maximum reward. Okay, it gives me 65, which is more than any other policy would give me. Okay, so if I go from ABD, it would be 40. When you compare this to ACD, it gives me more reward. So obviously, I'm going to go with ACD. Okay, so guys, this was a simple problem in order to understand how Markov decision process works. All right. So guys, I want to ask you a question. What do you think I did here? Did I perform exploration or did I perform exploitation? Now the policy for the above example is of exploitation because we didn't explore the other nodes. Okay, we just selected 3 nodes and we traversed through them. So that's why this is called exploitation. We must always explore the different nodes so that we can find a more optimal policy. But in this case, obviously ACD has the highest reward and we're going with ACD. But generally, it's not so simple. There are a lot of nodes. There are hundreds of nodes to traverse and there are like 50, 60 policies. Okay, 50, 60 different policies. So you make sure you explore through all the policies and then decide on an optimum policy, which will give you a maximum reward. So guys, before we perform the hands-on part, let's try to understand the math behind our demo. Okay. So in our demo, we'll be using the 𝐶-learning algorithm, which is a type of reinforcement learning algorithm. Okay. It's simple. It just means that you have to take the best possible actions to reach your goal or to get the most rewards. All right. Let's try to understand this with an example. So guys, this is exactly what will be running in our demo. So make sure you understand this properly. Okay, so our goal here is we're going to place an agent in any one of the rooms. Okay, so basically these squares you see here are rooms. Okay, 0 is a room, 4 is a room, 3 is a room, 1 is a room, and 2 is a room. 5 is also a room. It's basically a way outside the building. All right, so what we're going to do is we're going to place an agent in any one of these rooms, and the goal is to reach outside the building. Okay, outside the building is room number 5. Okay. So these empty spaces are basically doors, which means that you can go from 0 to 4. You can go from 4 to 3, 3 to 1, 1 to 5, and similarly 3 to 2. But you can't go from 5 to 2 directly. All right. So there are certain set of rooms that don't get connected directly. Okay. So like I've mentioned here, each room is numbered from 0 to 4, and the outside of the building is numbered as 5. And one thing to note here is room 1 and room 4 directly lead to room number 5. All right, so room number 1 and 4 will directly lead out to room number 5. So basically our goal over here is to get to room number 5. Okay, to set this room as a goal, we'll associate a reward value to each door. Okay, don't worry, I'll explain what I'm saying. So if you represent these rooms in a graph, this is how the graph is going to look. Okay, so for example, from 2, you can go to 3, and then 3 to 1, 1 to 5, which will lead us to our goal. These arrows represent the link between the doors. All right, this is quite understandable. Now our next step is to associate a reward value to each of these doors. Okay, so the rooms that are directly connected to our end room, which is room number 5, will get a reward of 100. Okay, so basically our room number 1 will have a reward 5. Now this is obviously because it's directly connected to 5. Similarly, 4 will also be associated with a reward of 100 because it's directly connected to 5. Okay, so if you go out from 4, it'll lead to 5. Now the other nodes are not directly connected to 5. So you can't directly go from 0 to 5. Okay, so for this, we'll be assigning a reward of 0. So basically, other doors not directly connected to the target room have a 0 reward. Okay, now because the doors are two-way, the 2 arrows are assigned to each room. Okay, you can see 2 arrows assigned to each room. So basically 0 leads to 4 and 4 leads back to 0. Now we've assigned 0, 0 over here because 0 does not directly lead to 5. But 1 directly leads to 5, and that's why you can see 100 over here. Similarly, 4 directly leads to our goal state, and that's why we've assigned 100 over here. And obviously 5 to 5 is 100 as well. So here all the direct connections to room number 5 are rewarded 100, and all the indirect connections are rewarded 0. So guys, in 𝐶-learning, the end goal is to reach the state with the highest reward so that the agent arrives at the goal. Okay. So let me just explain this graph to you in detail. Now these rooms over here labeled 1, 2, 3 to 5, they represent the state an agent is in. So if I state 1, it means that the agent is in room number 1. Similarly, the agent's movement from one room to the other represents the action. Okay, so if I say 1 to 3, it represents an action. All right. So basically the state is represented as node and the action is represented by these arrows. Okay, so this is what this graph is about. These nodes represent the rooms and these arrows represent the actions. Okay, let's look at a small example. Let's set the initial state to 0. So my agent is placed in room number 2 and he has to travel all the way to room number 5. So if I set the initial stage to 2, he can travel to state 3. Okay, from 3 he can either go to 1 or he can go back to 2 or he can go to 4. If he chooses to go to 4, it will directly take him to room number 5, okay, which is our end goal. And even if he goes from room number 3 to 1, it will take him to room number 5. So this is how our algorithm works. It's going to traverse different rooms in order to reach the goal room, which is room number 5. Now let's try and depict these rewards in the form of a matrix, okay, because we'll be using this R matrix or the reward matrix to calculate the Q value or the Q matrix. Okay, we'll see what the Q value is in the next step. But for now, let's see how this reward matrix is calculated. Now the minus ones that you see in the table, they represent the null values. Now these minus 1 basically means that wherever there is no link between nodes, it's represented as minus 1. So 0 to 0 is minus 1, 0 to 1, there is no link. Okay, there's no direct link from 0 to 1, so it's represented as -1. Similarly, 0 to 2 also there is no link. You can see there's no line over here. So this is also -1. But when it comes to 0 to 4, there is a connection and we have numbered it 0 because the reward for a state which is not directly connected to the goal is 0. But if you look at this 1, 5, which is basically traversing from node 1 to node 5, you can see the reward is 100. Okay, that's basically because 1 and 5 are directly connected and 5 is our end goal. So any node which is directly connected to our goal state will get a reward of 100. Okay, that's why I've put 100 over here. Similarly, if you look at the fourth row over here, I've assigned 100 over here. This is because from 4 to 5, there is a direct connection. There's a direct connection which gives them a 100 reward. Okay, you can see from 4 to 5, there is a direct link. Okay, so from room number 4 to room number 5, you can go directly. That's why there's a 100 reward over here. So guys, this is how the reward matrix is made. All right, I hope this is clear to you all. Okay, now that we have the reward matrix, we need to create another matrix called the Q matrix. Okay, here you'll store all the Q values that we'll calculate. Now this Q matrix basically represents the memory of what the agent has learned through experience. Okay, so once he traverses from one room to the final room, whatever he's learned is stored in this Q matrix. Okay, in order for him to remember that the next time he traverses, we use this matrix. Okay, it's basically like a memory. So guys, the rows of the Q matrix will represent the current state of the agent. The columns will represent the possible actions. And to calculate the Q value, you use this formula. All right, I'll show you what the Q matrix looks like. But first, let's understand this formula. Now, this Q value we're calculating because we want to fill in the Q matrix. Okay, so this is basically a Q matrix over here. Initially, it's all 0. But as the agent traverses from different nodes to the destination node, this matrix will get filled up. Okay, so basically it'll be like a memory to the agent. He'll know that, okay, when he traversed using a particular path, he found out that his value was maximum or his reward was maximum over here. So next time he'll choose that path. This is exactly what the Q matrix is. Okay, let's go back. Now guys, don't worry about this formula for now because we'll be implementing this formula in an example in the next slide. Okay, so don't worry about this formula for now. But here, just remember that this Q basically represents the Q matrix, the R represents the reward matrix, and the gamma is the gamma value, which I'll talk about shortly. And here, you're just finding out the maximum from the Q matrix. So basically, the gamma parameter has a range from 0 to 1. So you can have a value of 0.1, 0.3, 0.5, 0.8, and all of that. So if the gamma is closer to 0, it means that the agent will consider only the immediate rewards, which means that the agent will not explore the surrounding. Basically, it won't explore different rooms. It'll just choose a particular room and then it'll try sticking to it. But if the value of gamma is high, meaning that if it's closer to 1, the agent will consider future rewards with greater weight. This means that the agent will explore all the possible approaches or all the possible policies in order to get to the end goal. So guys, this is what I was talking about when I mentioned exploitation and exploration. Alright, so if the gamma value is closer to 1, it basically means that you're actually exploring the entire environment and then choosing an optimum policy. But if your gamma value is closer to 0, it means that the agent will only stick to a certain set of policies and it will calculate the maximum reward based on those policies. Now next we have the Q-learning algorithm that we're going to use to solve this problem. So guys, now this is going to look very confusing to y'all. So let me just explain this with an example. Okay, we'll see what we're actually going to run in our demo. We'll do the math behind it and then I'll tell you what this Q-learning algorithm is. Okay, you'll understand it as I'm showing you the example. So guys, in the Q-learning algorithm, the agent learns from his experience. Okay, so each episode, which is basically when the agent starts traversing from an initial room to the end goal, is equivalent to one training session. And in every training session, the agent will explore the environment. It'll receive some reward until it reaches the goal state, which is 5. So guys, the purpose of training is to enhance the brain of our agent. Okay, only if he knows the environment very well, will he know which action to take. And this is why we calculate the Q matrix. Okay, in Q matrix, we're just going to calculate the value of traversing from every state to the end state, from every initial room to the end room. Okay, so when we calculate all the values or how much reward we are getting from each policy that we take, we know the optimum policy that will give us the maximum reward. Okay, that's why we have the Q matrix. This is very important because the more you train the agent and the more optimum your output will be. So basically here the agent will not perform exploitation. Instead, he'll explore around and go back and forth through the different rooms and find the fastest route to the goal. All right, now let's look at an example. Okay, let's see how the algorithm works. Okay, let's go back to the previous slide. And here it says that the first step is to set the gamma parameter. Okay, so let's do that. Now the first step is to set the value of the learning parameter, which is gamma, and we've randomly set it to 0.8. Okay, the next step is to initialize the matrix Q to 0. Okay, so we've set matrix Q to 0 over here, and then we'll select the initial stage. Okay, the third step is select a random initial state, and here we've selected the initial state as room number 1. Okay, so after you initialize the matrix Q as a 0 matrix, from room number 1, you can either go to room number 3 or room number 5. So if you look at the reward matrix, you can see that from room number 1, you can only go to room number 3 or room number 5. The other values are -1 here, which means that there is no link from 1 to 0, 1 to 1, 1 to 2, and 1 to 4. So the only possible actions from room number 1 is to go to room number 3 and to go to room number 5. All right. Okay, so let's select room number 5. Okay, so from room number 1, you can go to 3 and 5, and we have randomly selected 5. You can also select 3, but for example, let's select 5 over here. Now from room 5, you're going to calculate the maximum Q value for the next state based on all possible actions. So from room number 5, the next state can be room number 1, 4, or 5. So you're going to calculate the Q value for traversing 5 to 1, 5 to 4, 5 to 5, and you're going to find out which has the maximum Q value, and that's how you're going to compute the Q value. So let's implement our formula. Okay, this is the Q learning formula. So right now we are traversing from room number 1 to room number 5. Okay, this is our state. So here I've written Q1, 5. Okay, 1 represents our current state, which is room number 1. Okay, our initial state was room number 1, and we are traversing to room number 5. Okay, it's shown in this figure, room number 5. Now for this, we need to calculate the Q value. Next in our formula, it says reward matrix, state, and action. So the reward matrix for 1, 5, let's look at 1, 5. 1, 5 corresponds to 100. Okay, so our reward over here will be 100. So our 1, 5 is basically 100. Then you're going to add the gamma value. Now the gamma value, we've initialized it to 0.8. So that's what we've written over here. And we're going to multiply it with the maximum value that we're going to get for the next state based on all possible actions. Okay, so from 5, the next state is 1, 4, and 5. So if you traverse from 5 to 1, that's what I've written over here. 5 to 4, you're going to calculate the Q value of 5 to 4, and 5 to 5. Okay, that's what I mentioned over here. So Q5, 1, 5, 4, and 5, 5 are the next possible actions that you can take from state 5. So our 1, 5 is 100. Okay, because from the reward matrix, you can see that 1, 5 is 100. 0.8 is the value of gamma. After that, we'll calculate Q of 5, 1, 5, 4, and 5, 5. Like I mentioned earlier that we're going to initialize matrix Q as 0 matrix. So we're setting the value as 0 because initially, obviously, the agent doesn't have any memory of what is happening. Okay, so he's just starting from scratch. That's why all these values are 0. So Q of 5, 1 will obviously be 0, 5, 4 will be 0, and 5, 5 will also be 0. And to find out the maximum between these, it's obviously 0. So when you compute this equation, you'll get 100. So the Q value of 1, 5 is 100. So if our agent goes from room number 1 to room number 5, he's going to have a maximum reward or a Q value of 100. All right. Now in the next slide, you can see that I've updated the value of Q of 1, 5. Okay, it's set to 100. All right. Now similarly, let's look at another example so that you understand this better. So guys, this is exactly what we're going to do in our demo. It's only going to be coded. Okay, I'm just explaining our code right now. I'm just telling you the math behind it. All right. Now let's look at another example. Okay, this time we'll start with a randomly chosen initial state. Let's say that we've chosen state 3. Okay, so from room 3, you can either go to room number 1, 2, or 4. Randomly, we'll select room number 1. And from room number 1, you're going to calculate the maximum Q value for the next state based on all possible actions. So the possible actions from 1 is to go to 3 and to go to 5. Now, if you calculate the Q value using this formula, so let me explain this to you once again. Now, Q3, 1 basically represents that we're in room number 3 and we're going to room number 1. Okay, so this represents our action. Okay, so we're going from 3 to 1, which is our action, and 3 is our current state. Next, you'll look at the reward of going from 3 to 1. Okay, if you go to the reward matrix, 3, 1 is 0. Okay, now this is because there's no direct link between 3 and 5. Okay, so that's why the reward here is 0. So the value here will be 0. After that, we have the gamma value, which is 0.8. And then we're going to calculate the Q max of 1, 3 and 1, 5. Out of these, whichever has the maximum value, we're going to use that. Okay, so Q of 1, 3 is 0. All right, it's 0. You can see here 1, 3 is 0. And 1, 5, if you remember, we just calculated 1, 5 in the previous slide. Okay, 1, 5 was 100. So here I'm going to put 100. So the maximum here is 100. So 0.8 into 100 will give us 80. So that's the Q value we're going to get if you traverse from 3 to 1. Okay, I hope that was clear. So now we've traversed from room number 3 to room number 1 with a reward of 80. Okay, but we still haven't reached the end goal, which is room number 5. So for our next episode, the state will be room number 1. So guys, like I said, we'll repeat this inner loop because room number 1 is not our end goal. Okay, our end goal is room number 5. So now we need to figure out how to get from room number 1 to room number 5. So from room number 1, you can either go to 3 or 5. That's what I've drawn over here. So if we select 5, we know that it's our end goal. Okay, so from room number 5, then you have to calculate the maximum Q value for the next possible actions. So the next possible actions from 5 is to go to room number 1, room number 4 or room number 5. So you're going to calculate the Q value of 5 to 1, 5 to 4 and 5 to 5 and find out which is the maximum Q value here, and you're going to use that value. All right, so let's look at the formula now. Now again, we're in room number 1 and we want to go to room number 5. Okay, so that's exactly what I've written here, Q 1, 5. Next is the reward matrix. So reward of 1, 5, which is 100. All right. Then we've added the gamma value, which is 0.8. And then we're going to find the maximum Q value from 5 to 1, 5 to 4 and 5 to 5. So this is what we're performing over here. So 5, 1, 5, 4 and 5, 5 are all 0. This is because we initially set all the values of the Q matrix as 0. So you get 100 over here. And the matrix remains the same because we already had calculated Q 1, 5. So the value of 1, 5 is already fed to the agent. So when he comes back here, he knows that, okay, he's already done this before. Now he's going to try and implement another method. Okay, he's going to try and take another route or another policy. So he's going to try to go from different rooms and finally land up in room number 5. So guys, this is exactly how our code runs. We're going to traverse through each and every node because we want an optimum policy. Okay, an optimum policy is attained only when you traverse through all possible actions. Okay, so if you go through all possible actions that you can perform, only then will you understand which is the best action which will lead us to the reward. I hope this is clear. Now let's move on and look at our code. So guys, this is our code and this is executed in Python, and I'm assuming that all of you have a good background in Python. Okay, if you don't understand Python very well, I'm going to leave a link in the description. You can check out that video on Python and then maybe come back to this later. Okay, but I'll be explaining the code to you anyway. But I'm not going to spend a lot of time explaining each and every line of code because I'm assuming that you know Python. Okay, so let's look at the first line of code over here. So what we're going to do is we're going to import NumPy. Okay, NumPy is basically a Python library for adding support for large multi-dimensional arrays and matrices. And it's basically for computing mathematical functions. Okay. So first we're going to import that. After that, we're going to create the R matrix. Okay, so this is the R matrix. Next, we're going to create a Q matrix, and it's a 6 into 6 matrix because obviously we have 6 states starting from 0 to 5. Okay, and we're going to initialize the value to 0. So basically the Q matrix is going to be initialized to 0 over here. All right, after that, we're setting the gamma parameter to 0.8. So guys, you can play with this parameter and, move it to 0.9 or move it lower to 0.8. Okay, you can see what happens then. Then we'll set an initial stage. Okay, initial stage is set as 1. After that, we're defining a function called available actions. Okay, so basically what we're doing here is, since our initial state is 1, we're going to check our row number 1. Okay, this is our row number 1. Okay, this is row number 0, this is row number 1, and so on. So we're going to check the row number 1 and we're going to find the values which are greater than or equal to 0. Because these values basically represent the nodes that we can travel to. Now, if you select -1, you can't traverse to -1. Okay, I explained this earlier. The -1 represents all the nodes that we can't travel to, but we can travel to these nodes. Okay, so basically over here, we're checking all the values which are equal to 0 or greater than 0. These will be our available actions. So if our initial state is 1, we can travel to other states whose value is equal to 0 or greater than 0. And this is stored in this variable called available act. All right. Now this will basically get the available actions in the current state. Okay, so we're just storing the possible actions in this available act variable over here. So basically over here, since our initial state is 1, we're going to find out the next possible states we can go to. Okay, that is stored in the available act variable. Now next is this function chooses at random which action to be performed within the range. So if you remember over here, so guys, initially we are in stage number 1. Okay, our available actions is to go to stage number 3 or stage number 5. Sorry, room number 3 or room number 5. Okay, now randomly we need to choose one room. So for that, we're using this line of code. Okay, so here we're randomly going to choose one of the actions from the available act. This available act, like I said earlier, stores all our possible actions, okay, from the initial state. Okay, so once it chooses an action, it's going to store it in next action. So guys, this action will represent the next available action to take. Now next is our Q matrix. Remember this formula that we used. So guys, this formula that we use is what we're going to calculate in the next few lines of code. So in this block of code, we're just executing and computing the value of Q. Okay, this is our formula for computing the value of Q. Current state, comma action, R current state, comma action, gamma into the maximum value. So here basically we're going to calculate the maximum index, meaning that we're going to check which of the possible actions will give us the maximum Q value. All right, if you remember in our explanation over here, this value over here, max Q of 5,1, 5,4 and 5,5, we had to choose a maximum Q value that we get from these three. So basically that's exactly what we're doing in this line of code. We're calculating the index which gives us the maximum value. After we finish computing the value of Q, we'll just have to update our matrix. After that, we'll be updating the Q value and we'll be choosing a new initial state. Okay, so this is the update function that is defined over here. Okay, so I've just called the function over here. So guys, this whole set of code will just calculate the Q value. Okay, this is exactly what we did in our examples. After that, we have the training phase. So guys, remember, the more you train an algorithm, the better it's going to learn. Okay, so over here, I've provided around 10,000 iterations. Okay, so my range is 10,000 iterations, meaning that my agent will take 10,000 possible scenarios and it'll go through 10,000 iterations to find out the best policy. So here exactly what I'm doing is I'm choosing the current state randomly. After that, I'm choosing the available action from the current state. So either I can go to stage 3 or stage 5. Then I'm calculating the next action and then I'm finally updating the value in the Q matrix. And next we just normalize the Q matrix. So sometimes in our Q matrix, the value might exceed. Okay, let's say it exceeded to 500, 600. So that time you want to normalize the matrix. Okay, we want to bring it down a little bit. Okay, because larger numbers we won't be able to understand and computation will be very hard on larger numbers. That's why we perform normalization. You're taking your calculated value and you're dividing it with the maximum Q value into 100. All right, so you're normalizing it over here. So guys, this is the testing phase. Okay, here you'll just randomly set a current state and you won't give in any other data because you've already trained a model. Okay, you're going to give a current state. Then you're going to tell your agent that, listen, you're in room number 1. Now you need to go to room number 5. Okay, so he has to figure out how to go to room number 5 because we've trained him now. All right, so here we've set the current state to 1 and we need to make sure that it's not equal to 5 because 5 is the end goal. So guys, this is the same loop that we executed earlier. So we're going to do the same iterations again. Now, if I run this entire code, let's look at the result. So our current state here we've chosen as 1. Okay, and if we go back to our matrix, you can see that there is a direct link from 1 to 5, which means that the route that the agent should take is 1 to 5. Okay, directly it should go from 1 to 5 because it will get the maximum reward like that. Okay, let's see if that's happening. So if I run this, it should give me a direct path from 1 to 5. Okay, that's exactly what happened. So this is the selected path. So directly from 1 to 5 it went and it calculated the entire Q matrix for me. So guys, this is exactly how it works. Now let's try to set the initial stage as, let's say 2. So if I set the initial stage as 2 and if I try to run the code, let's see the path that it gives. So the selected path is 2, 3, 4, 5. Now it chose this path because it's giving us the maximum reward from this path. Okay, this is the Q matrix that it calculated, and this is the selected path. Alright, so guys, with this we come to the end of this demo. So basically what we did was we just placed an agent in a room, random room, and we asked it to traverse through and reach to the end room, which is room number 5. So basically we trained our agent and we made sure that it went through all the possible paths to calculate the best path. Alright. So guys, with this we come to the end of today's demo. If you have any questions or queries related to our today's session, please comment your queries and we'll get back to you at the earliest. So guys, thank you so much for joining me today. Have a great day.